This video shows how to adjust the work plane and how to model members. We will also create sections and materials. Before we start modeling, we customize the work plane and the grid in RFEM. To do this, we click the respective icon in the toolbar. In the new window, you can create a user-defined coordinate system in the upper part and define the orientation of the work plane as well as the origin coordinates. To have faster access to the orientation of the work plane, you can also use the respective symbols in the toolbar. Let's set the orientation of our work plane to XZ. You can find the grid properties in the lower part of the window. You can show or hide the grid. Additionally, you can enter the number and the spacing of the grid points. You can also activate a dynamic grid that automatically adapts to the size of the model. In addition, you can activate the snap to grid points in this window. If needed, you can adjust the number of pixels controlling the snap distance. In this case, the cursor is pulled magnetically to the grid points when it is close to them. When we are satisfied with the settings, we confirm the data in the dialog box by clicking OK and can start with the modeling. No data have yet been defined in our structural model. We can recognize this by the fact that there is no drop-down menu under the basic objects in Data Navigator. First, we set nodes in the work window to define the start and end nodes of the members. This step is optional because you can also insert members without define the start and end nodes beforehand. However, it helps us to gain a better understanding of modeling. So let's click New Node in the toolbar. Now we can set a node using the dialog box or graphically with the crosshairs. We decide to enter the data graphically and click the origin. The coordinates on the crosshairs are very helpful because they show the exact position. The activated snap helps us to click the correct node. Since the column has a height of 4.5 meters, but the spacing of the grid points is 1 meter in all directions, there is no grid point at 4.5 meters that we can click. Therefore, we set the second node using the dialog box by entering the desired coordinates and then clicking Apply. To set our first member, we click on New Single Member. In the new window, we now define the properties of the member before we create it. In the Main tab, we first select the member type by expanding the respective list. Since we want to model a column, we select Beam as member type. Find more information about the individual member types in the link below the video. Further in the course of this tutorial series, we will become more familiar with other member types. Under Options, you find more properties that you can assign to the new member, such as hinges, eccentricities, and much more. At the beginning, we don't select anything, we just click the Section tab. In the Section Distribution area, all available distribution types are listed. The bitmap on the right of the window helps you to visualize the respective distribution type. In addition to a uniform section distribution, you can also consider a linear or tapered section distribution. In the next area, you can set the member rotation. For our column, we leave both options as default. In the Section with Material area, we will create a new section for the member start by importing it from the section library. In the Select Section from Library dialog box, the most common standardized and parametric sections are arranged in categories. In the Standardized Steel category, we select a rolled I-beam to display all available sections of this category. In this dialog box, we can now select the desired section for our column, but first we will familiarize ourselves with the options. In the upper left area, you can change the section category without leaving the window. Immediately below that, you can find various filters which help to clearly limit the selection. A new feature in RFEM 6 is the practical search function at the bottom of the window. Let's try it out by entering ePay 450. All available ePay 450 sections are now listed and we select the desired one. Afterwards, we have to create a new material for the section. To do this, we click the Import Material from Material Library function in the Material area. The Material Library is structured similarly to the section library. On the left are the filters, in the middle the respective list, and at the bottom the new search function. We would like to use the Steel S235 material for our steel section. In the region field, we select European Union, and in the material type field, we select steel. Now we have restricted the selection and can easily search for the desired material. We select Steel S235 and confirm by clicking OK in the dialog box. We have now defined the material of our section. Another helpful feature in RFEM 6 is the display of the unit stress diagrams for the sections. A kilonewton is applied as the load and the desired stress distribution is displayed from the list. In addition, the statical moments and the center of gravity as well as the shear center are displayed. Depending on the options set in the main tab and initially in the base data, additional tabs appear in the new member window. These tabs allow for further calculation parameters for the design. You can also add hinges and eccentricities. We'll do that later. Now we confirm the entry of the new member by clicking OK. We create the first column by clicking the previously created nodes one by one. We end the action by right-clicking or using the Escape key on the keyboard. Thus, we have inserted the first member of our structural model and we have also reached the end of today's tutorial. Till next time.